Hi, my name is Gayatri Menon, and I'm going to explain to you my lab. The point of this lab was to observe the effects that like and opposite charges have on each other. And from this, we could calculate certain values, such as the number of atoms on the piece of tape, which we got through calculating the charge on the piece of tape. We can first find out through a preliminary test that the piece of tape is actually positively charged. We did this by allowing the piece of tape to interact with the neutral and negatively charged object, the neutral object being my hand and the negatively charged object being a plastic pen rubbed in cloth. Another assumption that I had to make was the weight of the tape. I calculated this through obtaining values online. This value would be the weight per unit centimeter squared. I then compared this number to the actual length and width of my piece of tape and was able to obtain the mass from this. I needed the mass in order to calculate the gravitational force, which I could then equate against the electric force. The following video shows how the tape was positively charged. As you can see in this particular video, the tape is attracted to my hand, which is currently acting as a neutral object. I then allowed the actual experiment to take place. To do this, I stacked 3 books on either side and charged one piece of tape and stuck it on top of the books, with enough space underneath in order to fit another piece of tape and my hands. I then took another piece of tape, again charged, positively charged, and held it underneath. As you can see, there is some sort of repulsion as the upper tape does move. The following calculations show how I got to the charge of the single piece of tape. I first measured the weight of my piece of tape, which I ended up getting 1.05 times 10 to the negative 4 kilograms. I then applied this weight in the force equation and got 1.03 times 10 to the negative 3 newtons as my gravitational force acting downwards on the upper piece of tape. My measured value of when repulsion happened was at 3.5 centimeters. I then had to make the assumption that at this point the gravitational force was equivalent to the electric force. I was then able to equate the value I got for the gravitational force to the electric force equation. From this equation, the values that I do know are the separation distance, which is 0.035 meters, and the constant, which is 9e9. I was then able to calculate the charge from these values, and I got 1.2 times 10 to the negative 8 coulombs. The following calculations show how I then used this given charge to calculate the ratio of atoms that had lost electrons within the single piece of tape. The first thing I did was calculate the number of electrons that were lost from the positively charged piece of tape. I obtained this value to be 7.4 times 10 to the power of 10 electrons. I then used the area of one atom given in the information sheet and the area of the tape in order to calculate the number of atoms that were present on the single piece of tape. This allowed me to get the number of atoms as 2.4 times 10 to the power of 17. I then calculated the ratio of atoms that lost electrons by doing the total number of electrons divided by the total number of atoms. In this glow script code, I basically did exactly what I did in the calculations, however, I used the values in vector form. This allowed me to create arrows that give the direction and the magnitude of each of the forces. This is the outcome of my glow script code. From this, you can see that the direction of the gravitational force and the electric force are in the opposite direction, with the electric force going up and the gravitational force going down. You can also see that on the second particle at the bottom, the electric force is going in the opposite direction to the original electric force on the first particle. This is due to the repulsion within the atoms.